In July of 2012, a cloud of plasma larger than the Earth tore across our planet's orbit at over 4 million kilometers an hour. It carried the magnetic fury of billions of nuclear bombs. But the Earth was not there. We had passed that exact point in space just 9 days earlier. 9 days! That is the entire margin by which modern civilization was not thrown back into the 19th century. This was not a hypothetical. It already happened. And here's the part nobody wants to say out loud. The next one is not a question of if. It is a question of when and of whether we will see it coming. The sun looks constant, a steady lamp that rises, sets, and asks nothing of us. But that calm is a lie told by distance. Our star is a churning nuclear furnace wrapped in a magnetic field that twists, tangles, and violently snaps. When it snaps, it hurls a piece of itself into space. We call the flash a solar flare. We call the cloud a coronal mass ejection. And roughly every 11 years, the sun works itself into a fever. Dark spots crawl across its face. The field grows unstable, and every so often it fires a shot in our direction. We have survived every shot so far, but we have never been this fragile, because everything we now depend on runs on something the sun can reach out and touch: electricity. Strip that single thread away, and everything else unravels with it. Water arrives in your home because a pump is running somewhere. Food stays fresh because a compressor is humming. Hospitals, banks, traffic, the internet, the cold chain that carries medicine across a continent, all of it is scaffolding built on top of a steady flow of current. We have wrapped our entire civilization around the assumption that the power stays on. And the one thing capable of switching it off across half a planet in a single afternoon is not a war or a machine of our own making. It is the star we were born beneath. To understand the danger, you have to understand what the sun actually is. It is not a ball of fire. It is a sphere of plasma, a fourth state of matter where atoms are torn into charged particles. Those charges carry the sun's magnetic field like threads woven through boiling soup. Near a sunspot, those threads knot together, storing energy the way a twisted rubber band stores it. When the tension finally releases, the snap unleashes a solar flare. In minutes, it can radiate the energy of billions of atomic bombs. And often, riding that same eruption, a coronal mass ejection lifts off. Picture billions of tons of the sun's own atmosphere, launched into space at millions of kilometers an hour. If you could stand near the surface and watch, you would see loops of glowing plasma arch higher than entire planets, then tear free, and there would be no sound to any of it. In the vacuum of space, the most violent event in the entire solar system unfolds in perfect silence. What travels toward us afterward is not noise, and it is not the searing heat you would expect from something born in the sun. It is magnetism and motion, a fist of charged particles flung across 150 million kilometers of emptiness. The light of the flare reaches us in 8 minutes and warns of nothing on its own. The cloud behind it is slower, but when its aim is good, it can close that vast distance in less than a day. The question is never whether the sun can hit us. It is whether we will be standing in the path when it does. We know exactly how bad this can get because it happened. On the 1st of September 1849, an English astronomer named Richard Carrington was sketching sunspots when the surface suddenly flared white. He was watching the most powerful solar storm in recorded history begin. 17 hours later, the cloud arrived. Normally, that journey takes days. This one crossed the distance in a single night because it was moving that fast. And then the sky came apart. Auroras that usually cling to the poles blazed over Cuba, over Hawaii, over the Caribbean. People woke in the middle of the night thinking dawn had come early. Some read newspapers by the crimson light. It was beautiful. It was also the first warning shot fired at a technological species, and almost no one who saw it understood what they were looking at. There was no such thing as space weather in 1859, no theory of a magnetic sun reaching invisibly across the void to shake the earth. People simply knew that for 2 nights the heavens had behaved as though the world were ending, glowing in colors that did not belong to any sky they knew. And then just as suddenly everything went quiet again. It would take more than a century of science to understand that the aurora over Cuba and the strange fire in the wires were the same event. Two faces of a single blow struck by the sun, because 1859 had one machine that could feel the storm, the telegraph. And the telegraph went mad. Across Europe and North America, lines threw sparks. Operators were shocked at their keys. Paper burst into flame. And then something impossible happened. Operators disconnected their batteries entirely, and the machines kept transmitting, powered by the storm itself. The Earth's own field had been shoved so hard that the ground was pushing current through the wires. In 1859, the world had a few thousand kilometers of telegraph line to punish. Today, the world is wired end-to-end. Every grid, every satellite, every hidden cable that keeps a city breathing is a wire the sun can push current through. Carrington saw the fuse. He could not see the bomb it was attached to. In his own lifetime, the damage looked almost trivial. A scattering of sparks, a few small fires, a handful of burned hands and ruined instruments. But hidden inside that curiosity was a rule that would only grow more dangerous with every decade that followed. The more wire a civilization strings across its world, the harder the sun is able to hit it. In 1859, that rule cost a few operators a bad night. Every year since, we have handed the sun a larger and larger target, and we have never once asked its permission. And Carrington was not even the worst. To find the worst, you have to read the sun's older diary, and the sun keeps its calendar in strange places, in the rings of ancient trees, in the layers of polar ice, in the year 774 and again in 993, radioactive carbon spiked worldwide, locked into that year's growth. Something had flooded the atmosphere with radiation. In 2012, physicist Miyake traced the signal to its source, the sun, firing an event perhaps 10 to 100 times stronger than Carrington. We now call them Miyake events. They are the ceiling. They tell us the sun is capable of blows far heavier than anything the age of electricity has ever witnessed. Somewhere in the tree rings of the future, one of those years is still waiting to be written. And unlike a comet or an asteroid, a Miyake event gives no long approach to track, no years of warning as it drifts closer across the dark. The sun offers nothing of the kind. The record buried in the trees and the ice tells us only two things, and both of them are unsettling. It has happened before, more than once, and there is nothing anywhere in physics that forbids it from happening again, within a single human life, perhaps within our own. So what actually breaks when the next one lands? It begins with the transformers. The giant machines that step power across the grid are vulnerable to the slow, creeping currents a solar storm drives through the ground. Those currents can overheat a transformer's core until it fails. And here is the quiet horror. The largest ones are custom built, weigh hundreds of tons, and can take months or years to replace. Lose enough of them at once, and the grid does not blink back on. Above us, satellites fry in the radiation. GPS drifts. Communications go dark. Flights over the poles lose contact and reroute. And we have already seen a rehearsal. In March of 1989, a far smaller storm hit Quebec, and the entire power grid collapsed in 90 seconds. 6 million people lost electricity in a single silent instant. That was the sun clearing its throat. And Quebec was not the sun at its full strength. It was a glancing blow, a modest storm striking a single grid, and even so it needed only 90 seconds to win. Now take that same reach and aim it not at one province, but at a hemisphere. Picture it falling on the giant transformers we cannot quickly replace, in cities that have long forgotten how to survive without power for even a single day. The lights in 1989 came back within hours. There is no law of nature that promises us the same the next time. We are not entirely helpless. 1.5 million kilometers sunward, spacecraft named DSCO-VR and ACE hang at a gravitational balance point, sniffing the solar wind. When a storm passes them, they give us a warning, but only minutes to an hour before it reaches us. In that window, operators can reduce load, ground transformers, and put satellites into safe mode. Preparation is the only real defense, Because we cannot stop a coronal mass ejection. We can only brace before the blow, and the odds are not comforting. Studies estimate the chance of another Carrington scale storm at something like 10% per decade. 10%. That is not a distant maybe. That is a coin the sun is quietly, endlessly flipping. And every decade that passes without a direct hit, the coin simply lands in our favor again. It is easy to mistake that streak for safety, but probability has no memory of the throws that came before. And a long run of luck is not the same thing as protection. The sun does not owe us the quiet century we happen to have enjoyed. It has never promised us anything at all. So return to that cloud in 2012, the one that missed us by 9 days. It was never a warning about the past. It was a rehearsal for the future. The same sun that grows our food and paints our skies is also the closest thing to a time bomb that our species has ever lived beside. It has fired on us before. It will fire on us again. The only open question is whether, on that day, our fragile web of light and current can survive the sky-catching fire. The sun keeps its own calendar, and somewhere on it, that date is already circled.